Radio. Welcome to part two. Um, so here we go. The graph shows the number of bacteria Y at time n minutes. Initially, when n equals 0, the bacteria is 1,000. Find the number of bacteria at 40 minutes. Nice and easy. Come along to 40. Go up until you hit the line. Go across. And we'll say 4,000. 4,000? Yeah, 4,000. Okay, nice and easy. So the number of bacteria can be modeled by using the equation that y equals a times b to the n, where a and b are constants. Use a guess and check method to find two decimal places and upper and lower estimate for the value of b. The upper and lower estimates need to be 0.01 apart. Okay, so sometimes you do get these guess and check ones, particularly for a harder function like this. So what it's saying, things you need to know. The A, so the A and the N. Okay, so when we set N to 0, which is over here, we have to know what value we get. And we got it, and it tells us 1,000. So we're going to say that A is equal to 1,000 because when I put Y is equal to, and I don't know this number, and I don't know A multiplied by some number to the power of 0. Now, any number to the times to the power of 0 is always going to be 1. So I'm going to write it like that. And I have to think to myself, what number can I multiply? What do I get when I multiply something by 1? I get itself. Okay, and so since this starts at 1,000, this first number has to be 1,000. Okay, now that might be really tricky, and that this is quite tough. I think this is band 5 or 6, so this is really tough. Now, what we need to do is we need to change some numbers around, and we got to find something for B. Okay, and what that means is I'm going to use. So I'm going to leave my 1,000 there. Multiply by something, and I'm going to say to the power of 40. Okay, why am I going to say to the power of 40? Because I know what the answer is to the power of 40. I should get 4,000. So when we put this into a calculator, what I'm trying to do is pick a number that that gets me very close to. I've got to be within 0.01 of 1,000. So let's try an easy one first. So we're going to say 1,000 multiply. I'm going to pick 1. 1 times 1 times something to the power of 40, which is what we just did. So that should be 1,000. And that's probably a silly guess now thinking about it. But let's try 2, right? 2. 2 to the power of 40. Whoa. That is massive. Okay. We got to reel it in a lot. So let's go down by halves. Let's call it 1.5. Okay, still a really massive number. Let's bring it down by another half again. Half of 0.5. Okay, we're getting closer. We're bringing in a little bit more. I'm going to bring in a lot, actually. Let's go 0.05. Ooh, 7,000. Okay, now we're getting really close to where I need to do. So let's just go down by 1. Let's go down by 1. Oh, 4,000. 4,800. All right, so that's above. And let's drop it down 1. Okay, and there's my 2 answers. The upper, use a guess and to find two decimal places. So B is going to be, because we're those last two, so we had 3,000, which is just below our answer. And if we go back to our last answer, so since these answers are giving us just above 4,000 and just below 4,000, that's as much accuracy as you need. So what we want, you can write it as this if you wanted to, 1.03 is less than B is less than 1.04, and that's super fancy. Or you could just write B, you could just actually write in words. Upper equals 1.04 and lower 1.03 if you don't like the super fancy one. But that is quite a difficult question. Let's go to some work with heart rates. So during a panic attack, Mike's heart rate rose to 250 beats per minute. Given his resting heart rate 75, calculate the ratio of his resting heart rate to his heart rate during his attack. Reduce fraction form. Okay, so again, this is just going to be 75 over 250. And we can do that in our calculator, which is nice and easy. So 75 over 250. So 3/10 equals 3/10. So that's reduced. To mitigate his panic disorder, Mike is doing breathing exercises during which his resting heart rate decreases by 20%. What's Mike's heart rate during his breathing exercises? Okay, so his resting heart rate was 75. So decreased by 20%. We're going to say 75. Now you can say times 20% and it's subtracted off. But what I'm going to do, I'm going to say multiplied by 80%. Okay, so it's reducing by 20%. So if I think 100, take off 20% gives me the 80%. That's how you do it. It's a nice little easy way to do it that way. So we can say 75 multiplied by, oops, I'll do it the other way, 80%. And that equals, not times the answer, equals 60. So his resting heart, what he needs to reduce it down to is 60. So a little bit of beats per minute there. Oh, all right. This was the answers for some reason because sometimes I'm smart. I did this like 2 days ago now, so I wish I'd have left them. But oh well. So Marissa invests $6,000 at a rate of 4% per annum, compounding interest over 6 years. From the graph, estimate the interest that she'll earn after 4.5 years. Okay, so again, just from the graph, just thought it'd be easier to use the graph. So roughly, in this way, you want to use a ruler. Remember, taking a ruler to your trial, about halfway. And if I was really on the ball, I'd measure this, but I can sort of see through it. How does that look? Yeah, far enough. Okay. And then we're going to go across. Bring it back to 0. There we go. Okay, so because this is a estimate, there is a bit of wriggle room, particularly like where you're saying you could have drawn your line slightly here, slightly here. Try get in the middle. There is a bit, the markers will give you a bit of wiggle room. But the only thing I'd say is don't say that it's 1,200. Don't say it's 1,000. So for me, I think I'm going to say 11,000. Oh, 1,100 and I'll go 1,100. Okay, I think that was one of the options for the answer. but that's what it's asking. So again, when it says use the graph, use the graph. Okay, don't go try work out the compound interest, because I think if you did it, it'd give you something very close. I've just said don't do it. Now I'm about to do it. Compounding interest per annum 1 plus 4%. And to the power of 4.5 minus 6,000, because it's only talking about interest. So there we go, 1,158. So from the graph, I did pretty good, and that's all you have to do. So don't do this part. I'm just reaffirming what I did. Whenever it says use graph, just use the graph. All right, and that's it for that one. So hopefully those little recordings help, and I'll see you guys in the next episode.